class 58 here. So let's get into it. The first page is just working with the work energy theorem. Second page, we talk about some new stuff. So the first question here, we do 150 joules of work. It asks for how much the total energy of the system increases by. That's your answer, 150 joules. By definition, work is equal to the change in total energy of the system. Next one's similar, but slightly more complicated or nuanced. In this question, we do 15 joules of work, and it asks for how much the kinetic energy increases by. Well, we know work is equal to change in total energy, so the answer isn't necessarily 15 because we're looking for kinetic here, but a couple things. This is a horizontal surface, which means there's no change in potential energy. The height's always the same. So that's 0. And it also says that it's frictionless. So there's no friction, no heat generated. So all we're left with is kinetic energy. So the change in kinetic energy is in fact 15 joules. This question here, finding the work done, simply find the area. The area of segment 1 is 1 times 10 to the 4 newtons times 3. The area of segment 2 is 2 times 10 to the 4 newtons times 6, because that base is only 6 there. Add those together, you get 15 times 10 to the 4, or 1.5 times 10 to the 5 joules. So if a student walks down a hill at constant speed, his gravitational potential energy, well, constant speed right there, you know the kinetic energy is constant. Now you might be thinking if something goes downhill, it speeds up. While that would be true, it's saying that the student is walking in such a way that he's maintaining a constant speed. Then what happens to the potential energy? Well, as you get lower, your height, your h value gets smaller. So your potential energy goes down as you go downhill. That's why I have answer choice D. And the last one here is basically saying if you double the mass, you double the potential energy. Here's an example. It says they're both at 1 meter height. They obviously little g is the same for both, and B is twice the mass. If you do MGH for both of those, you find that B has twice the potential energy. So that's a nice way to prove it using numbers if that's what works better for you. All right, so first we got to differentiate two things, mechanical energy and internal energy. Mechanical energy is potential energy and kinetic energy, the sum of the two. And internal energy is heat energy, abbreviated with a Q. So in this question here, you can read through it. First part is calculate the work done on the box by the student while pushing the box from the bottom of the incline. Well, the student applies 25 newtons of force and the student pushes the box 6 meters. So the work done is 150 joules. The next question says basically if there were more friction, what would happen to the work done? Well, if there were more friction, the student would have to apply more force, right? More than 25 newtons. So the amount of work done would go up. Next part, how much potential energy does the box gain when it reaches the top? So potential energy is mgh. Now, we're not given the mass here, but we're given mg, we're given the weight. So you can just take that 50 newtons and plug it right into mg. Some students don't like doing that. They like to divide this weight by 9.8 and then multiply, then throw it in here, which you end up multiplying by 9.8 again with the g. So it's really up to you. Anyway, we get 100 joules. So where did the other 50 joules go? Does this violate the work energy theorem? Obviously it doesn't. So where did it go? Well, it went to heat. Why? Well, we know that work equals change in total energy, and the total energy is comprised of potential, kinetic, and Q. There is no change in kinetic energy because the question states that this is constant velocity. So if we start plugging in, 150 is the work, potential energy change is 100, so that means that Q has to be 50. This question is pretty similar. So we're looking for the work done by the rope, which ends up being 36,340 joules. And the skier gains 28,224 joules of potential energy. So again, where did the other energy go? Well, let's kind of go through the math and just look, although the next question isn't even asking that, but let's just look. So again, change in kinetic energy is 0 because it states that it's a constant speed. So I think the change in heat or internal energy ends up being about 8,000 joules. So what happens to the internal energy of the system? It increases. We got 8,000 joules of heat. What happens to the mechanical energy? Well, that's potential and kinetic. Did we gain potential and kinetic energy? I think so. I think we gained like 28,000 joules of potential energy. You might be saying, but we didn't gain any kinetic. Well, it doesn't matter because it's the sum of the two. Did the sum of the two get bigger? Yeah, it did. It went from 0 to 28,000. And there we have it.